In the summer of 1994, Jupiter shielded Earth from the equivalent of 2 billion atomic bombs. All of humanity witnessed a comet, like an out-of-control suicide train, violently crashing into Jupiter. The energy released in an instant was equivalent to 2 billion Hiroshima bombs, tens of thousands of times greater than the total nuclear arsenal on Earth. If that string of cosmic pearls had hit Earth, we wouldn't even have had time to write our last words. This was not a science fiction movie, but the only time in human history that we have personally witnessed a destructive collision between celestial bodies in the solar system. Its name was Comet Shoemaker, Levy 9. The story begins on March the 24th, 1993, at the Palomar Observatory in the United States. Eugene Shoemaker and his wife were conducting routine observations as usual. When they developed the photos from that night, everyone froze. A normal comet looks like a blurry cotton ball, but this one looked like a stretched string of pearls in space, with dense cores lined up in a row. When the Hubble Space Telescope focused on the target, the truth made astronomers around the world break out in cold sweat. This originally intact comet had made a fatal mistake. It had entered Jupiter's Roche limit. Within this distance, Jupiter's terrifying tidal forces tore the comet apart, like snapping a biscuit, breaking it into 21 major fragments. This string of pearls was not just passing by. It had turned around and was heading straight toward Jupiter, ready to meet its end. Calculations of its orbit clearly showed the impact would occur between July the 16th and July the 22nd, 1994. The news shocked the world. This was an unprecedented opportunity in the history of astronomy. Humanity mobilized all its top technology. The Hubble Space Telescope locked firmly onto Jupiter. The Galileo probe adjusted its position to observe the entire event, and Voyager 2 turned back from 6 billion kilometers away to watch. All major telescopes on Earth paused their other projects and pointed toward Jupiter. All of humanity's attention was focused on this cosmic catastrophe. At the time, the scientific community was still arguing fiercely. Some traditional astronomers believed it would be a dud, that the comet fragments were too small compared to Jupiter, like throwing a handful of sand into the ocean. They thought Jupiter's thick atmosphere would swallow them silently, at most causing a small ripple, posing no real threat. But soon, everyone fell silent. At 8 p.m., on July the 16th, 1994, the first fragment plunged into Jupiter's atmosphere at a terrifying speed of 60 kilometers per second. However, because the impact occurred on the side of Jupiter, facing away from Earth, we could not see the moment of collision. Everyone stared at their telescopes, anxiously waiting for Jupiter's rotation to bring the impact site into view. When that location finally came into sight, the skeptics were instantly silenced. The surface of Jupiter showed a huge black scar. Even with a small telescope, this dark spot was clearly visible, like a wound carved into Jupiter. Infrared data showed that the impact site produced a massive fireball, with a temperature of 24,000 degrees Celsius, 4 times the temperature of the sun's surface. This was only the first fragment, and a relatively small one. The real nightmare had just begun. Over the following week, 21 fragments struck Jupiter, one after another, like a machine gun. Media around the world frantically broadcast this cosmic fireworks show, but no one was laughing. The most deadly one was Fragment G, on July the 18th. It was the largest piece of the comet, with a diameter of 1.5 to 3 kilometers. When it hit Jupiter, even this gas giant seemed to shake. The Galileo spacecraft witnessed a superheated fireball rising instantly, while images captured by the Hubble Space Telescope were even more shocking. The explosion produced a mushroom cloud that broke through Jupiter's dense atmosphere and shot up to an altitude of 3,000 kilometers. Mount Everest is only 8.8 kilometers high, and the International Space Station orbits at about 400 kilometers. This mushroom cloud reached a height greater than 1/3 of Earth's diameter. The energy released by this impact was estimated at 6 trillion tons of TNT, about 600 times the total nuclear weapons on Earth combined. The supersonic shockwave from the explosion tore open Jupiter's atmosphere, throwing deeper material high into the sky. Another black scar appeared, several times larger than the previous one. After the dust settled, this dark brown spot was even more noticeable than Jupiter's great red spot. It was larger than the entire Earth. Even if you put Earth into it, it might not completely fill the impact center. These black bruises remained on Jupiter's surface for months and were only gradually erased by Jupiter's storms after about a year. This live broadcast left all of humanity excited, but it also sent a chill down scientists' spines. Everyone was thinking the same question. What if that string of pearls had struck Earth instead of Jupiter? The answer is only 2 words: extinction. There would be no need for multiple fragments. Any single piece hitting Earth would be enough. If it struck land, it would instantly destroy an entire continent, triggering global earthquakes and volcanic eruptions. If it hit the ocean, it would generate tsunamis thousands of meters high, sweeping across all coastal cities. If multiple fragments hit Earth, everything within thousands of kilometers of the impact zone would be vaporized instantly. Superheated debris would fall back to Earth like a rain of fire, igniting global wildfires. Dust would block out the sun for years, plants would die, the food chain would collapse, and temperatures would plunge. This would be the greatest blow to life on Earth since the dinosaur extinction 65 million years ago. Human civilization would be completely wiped out. Even cockroaches might not survive. The extinction of the dinosaurs was caused by a single asteroid about 10 kilometers in diameter. The total mass, energy, and destructive power of Shoemaker, Levy 9 were on the same scale. The 1994 collision with Jupiter became a major turning point in the history of space science. Before this, asteroid impacts were seen as Hollywood fiction or distant prehistoric legends. After this event, everyone understood that the threat is real, and it could happen at any time. This event directly pushed the development of global near-Earth object defense systems. NASA and space agencies around the world invested heavily in building networks to track asteroids and comets that could threaten Earth. Today, we can monitor over 90% of near-Earth asteroids larger than 1 kilometer. Comet Shoemaker, Levy 9, at the cost of its complete destruction, gave humanity one of the most vivid survival lessons. Every mushroom cloud it created on Jupiter was a warning from the universe. We live in a violent cosmos. Survival has never been something guaranteed. It is a miracle that must be constantly protected with vigilance.